Hello everyone. In this video, we are going to talk about spreadsheet engineering. So what is spreadsheet engineering? Spreadsheet engineering is the process of designing, constructing, and testing spreadsheet models. Due to ease of use of spreadsheet software, business professionals are often tempted to jump right into the spreadsheet modeling project by entering formulas into spreadsheet. However, this approach often leads to critical design flaws or bugs that would require even more time and effort to fix in the future, or incorrect decision making if they are not detected. Careful planning and design can improve both the speed and quality of implementing spreadsheet models, both straightforward and complex. So in this section, I will introduce a valuable tool for spreadsheet engineering called an influence diagram, and I will show how it supports the design of spreadsheet models. A decision can be decomposed into its components, and this process allows even very complex decisions to be precisely specified and understood. A visual representation that illustrates the various components of a decision and their relationship is called an influence diagram. An influence diagram represents a conceptual model of business problem and shows the logic behind the decision-making process. It's especially useful in understanding the relation between inputs and outputs. The two key elements of an influence diagram are nodes, which are shown as ovals, and arrows. The nodes represents the decision variables, whereas the arrows represents the influence that variables have on other variables. An influence diagram usually starts with the final target output variable at the top, and continuously decomposes a decision to show how the intermediate output variables are influenced by the input variables at each level. So let's look at one example to illustrate how an influence diagram is constructed. Claire Wong, a graduating senior, is interested in constructing a spreadsheet model that would help her predict retirement savings over a 30-year career with disciplined contributions to her retirement account. First, we will create an influence diagram to illustrate the relationship between the input variables and the target outputs. Then we will convert the influence diagram into a spreadsheet model using the following assumptions. Claire will begin her career with a starting annual salary of $50,000. She will receive her first paycheck at the end of January in the first year, and there will be no interruption in her employment during the 30-year period. Claire will receive a constant salary increase of 3%, make a constant contribution of 10% of her salary toward retirement, receive a constant match of 4% of her salary from the employer, and generate an annual return of 6% on her investment. Initially, we assume that all contributions will be made at the beginning of the year, with the first annual contribution made at the outset before the salary is received. Finally, we will improve the spreadsheet model by changing the annual contributions and company matches to monthly contributions and company matches that are made at the end of each month. Here is the influence diagram. The target outputs of Claire's spreadsheet model are the ending balances, which is the balance of her retirement account over a 30-year period. And it's at the top as you see in the figure. The input variables for the model include Claire's annual salary, which is salary, contribution rate as a percentage of annual salary, which in the diagram it's contribution rate, company's match as a percentage of annual salary, which is match rate, salary increase rate, which is increase rate, and annual investment return rate, which is return rate. And these are all displayed in the influence diagram. The computation of the ending balance is based on the following formulas. Please note that the ending balance and salary of the current year are influenced by the ending balance and salary of the previous year, suggesting recurring calculations for these variables. So the first one, as you see here, is the top variable, which is balance, current year, is the sum of principal plus return. And we know principal is calculated balance prior year plus contribution plus the company match. And match returns are calculated by principal times return rate. Contributions are calculated salary, which is the current year salary, times contribution rate. Company match is salary current year times the match rate. And salary current year is salary prior year plus the increase rate. We now convert the influence diagram into an Excel spreadsheet model. A model is the generalization of a real-life scenario. Even with the best effort, a model may not account for all the variability in real life. We construct a spreadsheet model using the assumptions stated in the problem statements. Here in the figure displays the retirement calculator spreadsheet model and its formulas in the first 10 years. The formulas in the red boxes are the processes embedded in the model and were entered manually into the spreadsheet. The rest of the formulas were entered using the drag down option in Excel. So here you will see in this example computed values of the first 10 years for the retirement calculator. And you can see that at the end of the 10 year, the ending balance is 110,541.01. So in the next video, we will going to modify this problem and we are going to apply the formulas in the Excel worksheet. Thank you for watching this video.